Week 2, Assignment 2, Density-Dependent Limiting Factors. As I previously mentioned, limited resources or limiting factors. Today we'll look at how a particular type of limiting factor, density-dependent, is related to the spread of COVID-19 and other infectious diseases. As a reminder, a limiting factor is anything or any factor that limits the size or growth of a population. In doing so, it slows the growth and results in a stable population growth or a stable carrying capacity. There are two types of limiting factors. There are density independent limiting factors. These density independent limiting factors affect entire areas and do not depend on the density of a particular population. In this case, you're essentially in the wrong place at the wrong time. Examples of density independent limiting factors include natural disasters and weather, so things like floods or frost or drought where there is no water, and human activities like farming, deforestation, clear cutting where they cut down forests, spraying herbicides or pesticides. Oftentimes, these events will cause a population to suddenly crash and results in what is known as a boom and bust growth curve. If you look at that image, you can see the boom is when there's exponential growth and the population is skyrocketing. Bust is when it has an equally sharp decline after being affected by one of these density independent limiting factors. The other type of limiting factor is density dependent. This is a factor that does depend on the density of a population. But first, let's define what population density is. It's the number of individuals in a defined area. So, for example, the city of Minneapolis has an area of 57.49 square miles and has a population of 425,403 people. If we divide the population by the area, we find that the density is 7,334 people per square mile. Stillwater, for example, the city, has an area of 9 square miles and a population of 19,142. So the density of 19,142 over 9.07 is lower, approximately 2,110 people per square mile. Then we get into a table that shows the square miles, population, and density per square mile of Minneapolis, St. Paul, New York City, and San Francisco. Next, we'll move into a table titled Table 2. This table is comparing the density of each state. So it's looking at the entire size of the state in square miles and dividing the population of that state by it. You can see the states with the most dense population starts with the District of Columbia, Washington, D.C., being that it has a very small land area, only 61 square miles, but is still highly populated at almost 750,000 people. If we look all the way down at number 31, we'll find Minnesota. So these density-dependent limiting factors are the second type of limiting factor and don't usually affect small, scattered populations as much as they do large, dense populations. And because they affect dense populations, they usually result in increased competition. Think of our battle over toilet paper Purell and protective masks we've been having. Examples of density-dependent limiting factors include lack of a particular resource, so if there isn't enough food, water, space, shelter to support a population. Another factor could be predation or overcrowding, and of course, as we're looking at right now, disease is a density-dependent limiting factor. In the case of an infectious disease like COVID-19, the more people in a particular space, the more quickly the disease can spread. This is especially true for COVID-19, which is spread easily through respiratory droplets that can remain viable. The virus can remain alive and able to spread to a new person on different surfaces for quite some time, anywhere from 3 hours in the air up to 3 or 4 days on things like shopping carts and the glass at grocery stores or on your windows. So if you look below, if the droplets are just in the air, they can survive up to 3 hours hanging out in the air. If they're on cardboard, they can survive 1 full day. Steel or plastic can be up to 3 days. And finally, if it's on glass, the virus can live for 4 days and still infect you if you were to come in contact with it and get it into your respiratory system. So if we look at the areas in which COVID-19 is most quickly spreading, we can see some pretty expected correlations or connections. That top left green illustration shows the density of each state. The darker green, the higher the population density. To the right of it, show the number of confirmed COVID-19 cases. We can see that the states that have a higher population density also typically have a higher spread of COVID-19. States that have a lower population density typically have a lower spread of COVID-19. We also have the information broken down by county within each of these states. You can see areas that have the highest population density, that's the Twin Cities. Over here we can see very dense populations. This is the density of confirmed COVID-19 cases. We are in the middle of the most dense pocket in Minnesota and actually in the entire 5-state area. And again, this little section here that was super dense on our population map is also very dense on our people infected map. All right, if you would now please jump over to your Schoology assignment. There are, I believe, 4 questions for you to answer. Thank you. Take care.